we're going to find the volume of the solid formed by revolving the region bounded by the graph of square root of x and x squared about this line. Okay, first of all, let's get a visual for it. This is the region. This is what we're dealing with. Let's highlight it like we've been doing. There we go. And the top part is square root, that's f. The bottom part is x squared. So it might behoove us, there's that word again, I love the word behoove, to call this f of x and to call this one g of x, and that's just good to know. Okay, I'm writing in pencil because I might need that space later for erasures and other things. We're going to rotate this around the line y equals -1. It helps to get a visual, so let's draw the line y equals -1, which notice the scale we're on here. We're on a scale of 1/2. So we're going to rotate around this horizontal line right here. And as we do, we need to think about how this function is being redefined, okay? So what was square root of x is now, based on this translation, the square root of x and then plus 1, okay? And I'm also dealing with f first because it is the outermost function. So here we go. Let's use blue. The integral from, sliding up and down, getting whiplash here, from 0 to 1. And if you want me to prove that these truly intersect at 1 and at 0, yeah, we'll play that game, but let's not right now. 0 to 1. And it is a rotation, so we are dealing with the volume of a circle, the area of a circle, and it's the accumulated area of that. And we will have f of x and then plus 1. So this is going to be, we'll just call it what it is, square root of x, and then plus 1, and we're going to rotate that. That is the outermost function. This is f and then plus 1. So there's your plus 1, it's outermost. G is also the outermost, and I'm sorry, innermost. Wow. And it is x squared and then plus 1. We'll square that entire thing. All that goes in parentheses, and dx. We'll crank out an answer in a minute, but in the meantime, that is the setup. All right. Let's shift gears a little bit. We'll deal with that in a minute. We're going to now rotate around the line y equals 2. Okay, if I had a new line of rotation, I'm rotating around this line now, and we're rotating around this line, I have a different outer and a different inner and a different set of translations of my graph. That's what I'm really dealing with. And I also have a pencil that's not erasing very well, but you know what? I'm not going to argue because I found this pencil on the floor just before I started recording the video. I needed a pencil, there it was. So, do not mock your provision. Pi, 0 to 1. And we are going to be dealing with a different inner function and different outer function. The outermost function is now g, but it's not x squared, right? It's x squared, boom, boom, minus 2. So x squared minus 2. And we are, of course, are dealing with rotation. So we have basically a circle, pi r squared. Let's put it in the parenthesis. And then our inner function is the square root, and it would be shifted down to as well. So the square root of x and then minus 2. And then dx. Okay, let's crank out a couple answers very quickly just so we'll have the numerical answer, just in case you're wondering years down the road what that answer was that we never talked about. And here we go. There's that. 0 to 1 of square root of x plus 1, and then we square that, and then minus x squared plus 1, and then we're going to square that one. And dx, let's make sure everything is in order. Yep. That one's good. And then the second one. Pi, math, 9, 0 to 1. I like to type fast. And x squared minus 2 minus square root of x minus 2. And that one is also squared, as was the first one, I didn't say. And everything looks right to me. We'll press enter, we'll write down some answers. And now we're going to get to the really hard ones. 3.246 is this one. Ooh, wrong color. That one's blue and that one's black. Oh well. 3.03, to start all over now. Mess up the whole color scheme. Okay, now things get crazy. We're going to rotate around the line x equals -3. So let's do some erasing with this pencil I found on the floor. Gave you plenty of x-axis here to deal with, and we're going to rotate around this line. And if this is my axis of rotation, now we're rotating vertically. I know it says x equals -3, but it is a vertical rotation, as if it was around not the y-axis, but a y-axis. So let's set this thing up. Again, rotations involve a pi in the front because we're dealing with the accumulated area of a circle. And we're going to be going on the y-axis. So this is the y-axis, but this is what I'm referring to. We're going to be going on a vertical axis from a y value of 0 to a y value of 1. Okay, so let's not look at this and say, oh, well, nothing changes, 0 to 1. Well, because that's 0, 0, and that's 1, 1. That's why. And this is a vertical rotation. So this is dy, not dx. Okay. The outermost function, I would say it's g, and that's great, but let's switch colors here. Let's go green. We're going to say that we have g, which is y equals x squared. And that's what I have, but that's sort of not what I have. Okay, so I'm going to need some white out here in a second. If this was my y-axis, it's not. But if it was, the function would not be this. It would actually be that. Remember? Your x lied to you, so it was minus, so you went +3. So I need to solve this for y to be consistent with what I see here. So let's do it. Square root of y equals x minus 3. So x equals the square root of y and then +3. And by the way, what went through my head when I square rooted was, oh, do I take plus or minus? I take the plus. I take the positive end of that because I am dealing with the outermost end of that, not an innermost piece. So this. So we had the option at this point of picking positive or negative as we square rooted, but basically what I truly have is this edge of the parabola, not this edge. Okay? So when I said outer and inner a minute ago, I was not referring to outer and inner in terms of distance from our axis of rotation, so much as I was dealing with this would be away and this would be toward. Okay? All right. That sounded kind of like the same explanation, but let's just move on. That is the outer radius, so square root of y and then +3, and it is squared. Okay? Now we have the other function, and the other function is the square root, and it would be this. It would be this, but 3 away. Oops, let's put +3, be -3. My x lied to me there. That's the way we remember it. Your x lies to you, so you do the opposite when it's with the x. That's not always the case when we start graphing things in a different direction, but in this context, it's the opposite direction. So y squared equals x minus 3. So x equals y squared plus 3. That's my other function. Too late. All right, let's type this in. 0 to 1 and square root. I like to be consistent with my variables. That's what I do. And then +3, and then we'll square that, minus, and then y squared plus 3. And we'll square that, and that's going to be dy. Make sure we're good. Make sure everything's typed in there right. I do believe it is. There we go. We have an answer.